few things before we actually get started. The first one, raise your hand if you don't want to be in a selfie with me and you lot. Cool, I'm going to take that right now. Wonderful, that's going on Twitter later. Raise your hand if you really don't want me to post that on Twitter. It's okay, you can say so, right? Okay, cool. Second thing, I have a lot of these ducks with me. If you want one, come grab one. Close enough. I mean it, I have a lot, right? They're great for pairing because unlike a real pair, when you get annoyed, you can just hit them. And also they don't talk back as much and they let you code all the time, so they're much better than a real pair. My third point, I like questions, but I want to encourage you to ask questions throughout the talk. So I have a couple of little rules to make this go a bit more fluid. If you have a question, raise your hand. I might do this, which just means give me a minute. I'll get to the end of my point, and then I'm going to come to you, right? Because maybe I'm going to address your question in the next 2 seconds, in which case, it'll probably be easier that way. And actually, one more thing. I am a native English speaker, which means I will probably speak too fast at some point. Do this, it will tell me to slow down, okay? That will be really helpful. I can speak very slow. No, I won't do that. Okay, let's get started. What does it mean to be human? Well, Foucault said that. I don't speak French, so I'm not going to try and read that, but he said, I don't feel that it is necessary to know exactly what I am. The main interest in life and work is to become someone else that you were not in the beginning. Descartes said something much simpler that kind of has the same effect. I think, therefore I am. And I really thought I would be the first person to mention Sartre today, but that didn't happen. We are our choices. I'm not going to read the French. You'll be embarrassed, I'll be embarrassed. It's better for everyone if I just read the translation. Basically, humans are not very much like machines, right? Humans are perceptive, we make assumptions, we derive information from context. Machines do what they are told. So in this talk, I'm going to show you 3 experiments and kind of a potential future that we are imagining. I'm going to focus the first half on talking about why this is not as true as we might imagine, and the second half on why it doesn't matter. So Maxime, you've only seen the first half of this talk, so the second half should still be interesting. So, humans are awful at programming for all the above reasons, right? I'll give you an example. Who remembers leftpad? So leftpad is an infamous library that does one very useful thing in JavaScript. It pads things to the left. So if I give it 37, 5 digits, and pad with zeros, I get 0, 0, 0, 37. This is the implementation of leftpad. You don't have to read it, but it's actually, more complex than I would have thought. And I've removed a bunch of stuff because, well, there's just a cache thing. And I want to show you one commit that came in at one point, which was this one. There are 60 commits in leftpad, or just over 60. And this one converts your value that you give it to a string. Because if you give it a number like 37, well, it doesn't know how to pad that, but it does know how to pad the string 37. So this converts it to a string. Can you guess what the next commit is? I'll show you. It's this one. It will happen 2 minutes later. So rather than converting it to a string after we ask for a length, we convert it to a string before, because it turns out asking for a length of a number not very helpful. So I hate to tell you this, but computers are way better at finding these kinds of bugs than humans are. It's not that there's, humans are bad at reasoning about things, but rather we just don't bother most of the time. And that makes sense because we have tools to do the reasoning for us, like a type checker. A good type checker may have caught this, except a JavaScript type checker wouldn't because, well, JavaScript is a permissive language, and it turns out you can add a length property to basically anything. So sure, it probably has a length property. Even a type checker wouldn't catch it unless you gave it additional information, right? But dynamic languages have a power, right? It's really valuable to be able to write first and think later. Not always, but sometimes that's exactly what I need. I need to try something, see if it works, and then reason about why it works after I already understand just a little bit more. And with that power comes responsibility. The responsibility. Now you are responsible for making sure your code makes sense, not your compiler, not your type checker. You have linters in JavaScript, but they're half-baked because, well, anything can be anything. Oh, I don't want that responsibility, personally, because I'm not a machine. So I want to talk a bit about what your machine can do for you. So, okay, I have a quiz. What are the types of the parameters to this function? Shout. Say again, sorry? Yeah, it could be anything. It's probably like I mean, you and I know it's a number, but it could be anything. And the caller doesn't necessarily know that, right? I mean, here's the same function. Different names, same function. But now, it's fairly obvious to me that they're strings, I think. And this is a problem because, again, in JavaScript, did you know that the empty object plus the empty array is 0? I learned this last year because I was trying things out. There's a great talk by someone called Gary Bernhardt called WAT, W-A-T, which elaborates on this in detail if you're interested. Oh, I lost the duck. I want to show you something. This is an ML-based type inference tool that we built. Who can read this? Who can't read this? Wave. I saw someone put their glasses on at the back, so I'm going to zoom in a little bit. Hopefully that is a little bit readable. So I give this type checker, which uses some type information from a typical type checker, and then kind of does its own thing to ask what those types are. And it's 87% confident that X and Y are numbers, right? So this type checker we built in-house at a company I help run called Proto, and it's using graph modeling to kind of represent the data, like the code, just not as, well, often we think of these things as text, right? We look at code and go, okay, yeah, like function, add, x, y, like these are, but it's actually an abstract syntax tree, right? That's what we're dealing with. We deal with tree structures. We just happen to represent them as these kind of grids of text. And that's cool, but it doesn't give us the information we need half the time. And this is why, your actual type checker, especially if you deal with a statically typed language, if you write Java or etc., then your type checker is part of the compiler, and it will compile to a syntax tree before it tries to type check. And that's true of any other type checker, but with machine learning, most of this stuff has been limited to text because most advances in machine learning have been done in things like NLP, natural language processing, not neurolinguistic programming. That would be really cool if machines could do that, and slightly terrifying. I think that's the plot of Terminator. But they focus on things like natural language processing, which is why translation engines are really good now. I know because I managed to order food in a French restaurant, and they didn't laugh at me for at least 3 seconds. And images. That's the other thing we're very good at, right? But graphs are new. There's a lot of research going on. We are contributing, lots of other organizations, universities and and companies are contributing to the field of research that is graph-based machine learning. And this is about as good as we can get right now. We can tell that it's a number. You notice that there's a limited set of types we can deal with: object, string, function, number, undefined, array, Boolean, null, or any. Fortunately, it never predicts any, so we're at least going somewhere. I want to show you something. So if I change this to a concatenate function, now it's pretty certain that those are strings, right? And this is really helpful, not instead of your typical logic-based type checker, but as well as, right? Because it can make inferences that logic can't. Because if I think these are strings, we can then go and add those types in later, and then let the logic-based type checker propagate them outwards, or even propagate them out using machine learning, right? It can make assumptions of the sorts that you and I can, but a machine typically can't. I want to show you something else. This is much simpler, right? You can read that, right? What does it do? Nothing. Yeah, true. But you know what it's supposed to do. I think if I asked every single person in this room to fix this, make it work, unless you were trolling, you would fix it in exactly the same way, right? But a machine can't do it, right? So we had a weekend project where we were just messing around, and this is based on NLP techniques. Oh, okay, now I need to zoom out again. All right, you can just about read that. So giving the same information to a tool we call autofix, which I'm really hoping will be in an editor plugin sometime soon, it will just go and add that bracket back in. And it's trained on a lot of data about what code is supposed to look like, and it can predict that usually if something is following a value, if there's a square bracket somewhere in the statement, and if there isn't a closing square bracket, it probably goes before the semicolon. So it makes that guess, and it puts it in. And we're very proud of it because it almost never gets it wrong. Often it will do nothing, but it almost never gets it wrong, which is kind of where I want it to be. I would rather the tool did nothing than the wrong thing. So we're very happy about that. The point is that it turns out computers can make these kinds of judgments if we give them enough information. They need a lot more than you or I, right? A human can learn a new programming language and understand the syntax with probably a few files worth of information. You can understand roughly what this thing is going to do, especially if it looks similar to one you've seen before. But even if I showed you some Haskell code, you'd probably figure out that, okay, the brackets have to match up pretty quickly. It's not so true with programming, with computers, but they do figure it out eventually. It just takes approximately 100,000 to 1 million files to train them. So I care a lot about this one, right? Probably more than I should, because I really, really hate this kind of error. I really hate that when I copy something from one array into another array and I haven't put a comma in between, the tool just yells at me. I feel like it's slapping me on the wrist, and I feel like I'm being judged by my own technology, and this is very upsetting to me. Like, when I pair with a human being and they just, put a comma in when I didn't see, or they just nudge me and go, hey, you forgot a test case there, they're usually very gentle, at least the ones I like pairing with. But when I'm pairing with my compiler, it just shouts at me. It's like, wrong. I don't know what to do with this. You are wrong. And that happens about 1,000 times a day if I'm spending the whole day programming, and it's kind of upsetting. I want my tools to work with me, not against me. It's nice that they tell me when I'm wrong. I lost some ducks. But it would be nicer if they at least were nice about it, like they were gentle about it, and sometimes just did it because, well, come on, there's only one thing you can do here. Just do it, please. So what I'm asking you to do is to be dissatisfied. I don't want what we have now to be the end of it, right? Compilers have basically stayed the same for 30 years, maybe 40. they are cleverer, but they're not more useful. They take your code, they turn it into bits and bytes and machine language and bytecode and things like that that I can't read, but the computer can. But that's it. I want them to go further. Before I move on, any questions? It's okay, you don't have to have questions. I'll be here all day. I want to talk to you about symbiosis, because we learned something in the last year or so. We spent a lot of time being a research company, and it was a lot of fun. We got to make cool stuff, most of which I don't understand because I do the front end and the accounting and some of the legal stuff and other stuff that no one wants to do. But we realized something, which was that software is it doesn't understand everything about what it is to be a programmer. So we started exploring. I want to show you something. Again, zoom until we can see it. This is LeftPad, the actual implementation, and I put at the bottom 3 uses of LeftPad that are actually in the documentation. This is how it should work, right? And what it says, I realized that the syntax highlighting is making this very hard to read, so I'm just going to read it out for you. So if I leftpad the string foo to 5, I should get space, space, FOO. If I leftpad 1 to 2 characters, using the padding character of 0, I should get 0, 1. And if I leftpad 17 to 5 characters with 0, this time the integer 0, not the character 0, or the number, because JavaScript doesn't have integers, we'll talk about that later, I should get 0, 0, 0, 1, 7. But I introduced a bug in this, so actually what I get is foo is correct, and it doesn't pad the numbers. We built this tool, it's called Alfie, as an experiment because we were bored in November, and we really, really wanted something that we would enjoy using. We actually built this for Advent of Code, which is, for those of you who don't know, a fairly popular programming competition that happens in December every year. And we just wanted to make it easier for people to get started programming with algorithmic challenges. Maybe you're practicing for a job interview, maybe you're doing some katas, whatever it is. If you have to start setting up an environment, it's painful. So we built a thing that's kind of fun for us. And it was really important. We based this on a talk by Brett Victor called Inventing on Principle. If you haven't seen it, I recommend it. If you have seen it, I recommend it a second time. Where we question the need for a debugger, because a debugger is the developer asking questions of the software usually when something has gone wrong, or when they need to verify that something has gone right. But what if you could just have all the information straight away? So given the stuff on the right, can someone tell me where the bug is? Oh, you're all so shy. Go on. Line 16. Yeah. And so we can see that, right? The data tells us that we're getting nan, or not a number. Sorry, I should probably repeat what you said, because some people won't have heard it. It's on line 16. And we are asking for the length of something that is a number. Exactly the bug I showed you earlier, right? So if I were to say, put the fix in, you can see immediately that the data is updated, like the values that go through the system are updated to the correct thing. The length of 1 is 1, the length of 17 is apparently 3. Oh, the length of the, 5 minus 2 is 3. 5 minus 2 is 3, right? Okay, cool, my software works. Sorry, I'm really bad at maths. This is why I make tools to do it for me. Like, why am I doing this? This is what machines are for. This is kind of, I don't know. This is the feedback I always want from my tooling, but I can't always have it. It's easy for algorithms, right? Because you're working usually with numbers and strings and things where you don't have gigantic data structures that have to go over message queues. It's slightly harder for, real-world programming environments. But this is what I want from everything. I want it to just tell me what's wrong. And, as a human, you can look at, the broken implementation. Let me just go back to that. And, people are really good at pattern recognition. So your eyes just jump to the nan. If you've ever seen it before, your eyes just go, boom, there's the bug. Because you can see that there's a problem. I bet you, when you see a null in a giant log, your eyes just flash to it, right? We're really, really good at pattern recognition. Right? Daniel Kahneman calls this System 1 in his book, Thinking Fast and Slow, or something related to it anyway. I think System 1's a little bit deeper than that. But basically, we work on instinct most of the time. It's really effective, it's very efficient, and it gets us where we need to be most of the time. And computers don't really have that instinct. So while we can train machines to be instinctual about certain things, like putting a square bracket, it's hard. It takes a long time to figure out how to do that. But if you can give all the data to someone intelligent, well, they have the information. They can do something useful with it, right? And this symbiosis between human and machine, it turns out is really powerful. Contrary to popular belief, in 1997, when Deep Blue beat Garry Kasparov in chess, it wasn't actually the best chess player in the world, because the best chess players were not humans or machines, but humans who were using machines to get a competitive advantage. They could beat a computer 100 times out of 100. We can make smart decisions if we just have the information that we need, right? We're good at that. That's kind of how we are built. That's why humans can do all the things we do. I wanted to highlight some principles of the Agile Manifesto. Not the values, not the four things, although the first one's very interesting, at least in this context. I just pulled out a few phrases. Early and continuous delivery, changing requirements, deliver frequently, work together daily, face-to-face conversation, continuous attention enhances agility. The team reflects. When I look at these and I boil them down, what I really see is that the only thing that matters is feedback. More feedback, fewer problems, right? I can get stuff done faster, and if I can get stuff done faster, it's not just that I can fix the bug quicker, but the odds of the bug emerging in the first place are lower, right? So we really enjoyed building Alfie, but we stopped in December, right? Because while it was very interesting for us, and we learned loads, especially about how to do a lot of introspection in code, it's not something we can go to any one of you and say, hey, use this on your code base, because, well, you have to use our editor and you have to do everything in one file, and, there is no version control, and how do you ship it? You get the idea. But we had a real problem ourselves in building Alfie, partially, which is we wanted this kind of introspection and information, not just in the algorithms that we use, but also in the components that we use. So I want to introduce a new project. We released this for the first time yesterday. It is buggy as hell. It's been in development for less than a month. There have been 2 people working on it, and we're very, very, very proud of what we've done so far. And we call it Snoopy because we really like dogs. I should have put a picture in here of our office dog. I'll find one for you later. My colleague Tom, who helps found the company, has the most beautiful poodle cocker spaniel hybrid, and it makes going to the office every day worth it. So we really like dogs. We call this one Snoopy because, frankly, we want you to be lazy. This is Snoopy. It is very bare bones. Please don't judge our UI. We use it right now to build itself, right? I'm going to show you a very simple to-do application. You get the idea, right? This is a real application that I can run separately, but I'm just rendering the app component, the top-level component. For those of you who don't know how React works, this is all based on React. It's a declarative language that looks a bit like HTML, but allows you to embed JavaScript wherever you like. So you have this nice hybrid of imperative stuff when you need to get stuff done and manage state, and mostly declarative for actually rendering the components. If you've used Elm, it's the same, except with more syntax. It's what you expect. The important thing here is, it's on rendering issues. I told you it was buggy. Although this one is my fault because I set up this demo yesterday. If I want to work on a component, if I want to change things, I need to be able to see it not just in one state, but in every single possible state, right? So when I'm working on the list of tasks in my simple to-do list application, I don't want to just know what the list looks like with a bunch of stuff in it, but what it looks like with nothing in it, what it looks like when some stuff is done, what it looks like when I'm halfway through editing something. And I want to appreciate it. It's good when you get continuous feedback from your audience, right? Now imagine if your compiler gave you the same thing. And when I change stuff, and I want to see if I can get this going, let's see what happens. Ooh, okay. This is going to be fun. We're going to do some live coding that I totally didn't prepare for. Let's see what happens. So when I, for example, accidentally flip the done variable, I should, with a little bit of luck, no. Oh yeah, there we go. So it crosses off the wrong things, right? Because what I'm supposed to see is the checkbox is checked and it's crossed out, or neither. There we go. This is because I'm running it on a 4-year-old MacBook. So it's a very, very simple example. I don't mean to brag about this thing, but we're very proud of it, and I'll tell you why. I really, really hate making infrastructure decisions. And it turns out when you start a JavaScript project of any sort, but especially one with front-end stuff, you have to configure your bundler, which is usually Webpack and has infinite configuration. You have to decide which plugins you use. You even have to choose which variant of the language you want to use. We use TypeScript, some other people don't. This is really painful, right? And then you have to decide how you're going to write your tests. You have to decide how you're going to test your UI. And all of these things boil down to what we call integration fatigue. The idea that you spend way more time working on your infrastructure. And by infrastructure, I really mean anything that is not your domain. Anything that is not about your business. You see, you spend way more time working on that than you do actually solving business problems. So this is the present, right? You see one thing at a time when you're looking at your app. You have to debug your code. You have to figure out how your data in your database got that way by reading commits about your, in which you changed your SQL. You have to write UI tests, which take pictures not of the actual UI, but often, the HTML that was rendered or something like it. And you have to ship it to your customers and wait weeks to see if it actually works or not. And this is kind of how I imagine the future. We're just taking care of the first thing right now, but we're working on the rest as fast as we can. I want to see everything at once, not just even this component, but how is this component used in every single context it's used, in every single state that it can be in. I want to see a history of how everything got that way. I have no idea why we don't just have event sourcing by default for free in every single new project we ever write, but I totally want it to get there. Because I really need to know not just what the state of my system is, but what it was and how it was derived. I have no idea why we write UI tests, because UI is weird, right? When I write a unit test for a piece of business logic or even some infrastructure, usually there is a right answer. Whereas with UI, it's usually, this feels right. And I don't know how to test for feeling. But what I do know is that humans are really good at it. And so I don't need the machine to know what feels right. I just need to give the human the information as fast as possible and let them make a judgment call. And instead of waiting weeks to find out whether something works, I really want you to be able to get feedback at any moment just by sending a link to someone else. And I've been talking about front end because that's what we care about right now, but this should apply to anything, right? Like if you use Cucumber, I would love it if you could just get feedback on your specification immediately. If you send your data over message queues, it should be easy to understand whether your customers, your consumers, are getting the data in the format they expect, of the quality they expect. I just have one request from you when pushing towards this future. It turns out that analyzing software and trying to derive infrastructure for free is so much easier if your code is of a higher quality. There's a paper called On the Naturalness of Buggy Code, which explains that good code looks like other good code, but bad code, but code that is buggy, code that doesn't do what it expects, code that is overcomplicated, you get the idea, is highly divergent. Bad code doesn't look like other bad code. So if you write higher quality code, you are not just making it, writing fewer bugs, but you're also helping your colleagues to understand what is going on, not just because it's more readable or whatever, but because they've seen code like that before. Their pattern recognition can kick in, and instead of invoking what Daniel Kahneman calls System 2, where you actually have to, use your brain, you can use your pattern recognition, System 1, highly efficient, way faster, and as long as the code is of a good quality, the pattern recognition will mostly be correct. It's just when it kicks in for the bad code, then you have a problem. But weirdly, that's also what machines need. If I want to analyze your code with a static analysis, with machine learning, with anything in between, it's way easier to analyze high-quality code. If your data all flows through an event sourcing layer, the analysis is far, far easier than if you have SQL queries all over your application. If your front end uses state management libraries such as Redux or anything else where you have a concentrated place where you work with pure functions to iterate over data, it's just a lot easier to understand, both for a human and for a machine. My problem is that software developers forget that they are important. And Ulrika talked about this an hour ago, so I hope you remember what she said. Your job is to puzzle out what people mean, right? Your job as a software developer is to make sure that the software does what people expect. Your job is also to do it in an ethical manner and make sure everything is going well. But, boil it down. You transform ideas into logic. Ideas are vague. They'd miss out edge cases. They'd forget about things. They're internally inconsistent. And your job is to reason through all of those things. So I don't really want you to spend time figuring out why your infrastructure is broken. And by infrastructure, I really do mean anything that's not your domain. I want you to be figuring out the bugs in your domain, because those are way more important. That's what's going to lose you money. So I talked about what we're up to. I want to talk a little bit about what you're going to be doing. These are things we seem to care about as software developers. We care about things like cyclomatic complexity. We use tooling like PMD to measure it. We care about things like test coverage. These aren't questions, these are answers, right? And they're fixed answers. They don't get better over time. Again, we're stuck in the 1990s. Maybe in the 2000s. We didn't have acceptance tests in the 1990s, at least not by that name. But what I really care about is, how do we measure good design? And I bet there's a better answer than cyclomatic complexity, not because it's a bad answer, but because it's one answer. And maybe it works for you and maybe it doesn't. Like, do I really care about test coverage, or do I care that my software works? We're so used to these tools that kind of slap us on the wrist and tell us we're wrong. And I'm really, really looking forward to the day where I'm mobbing with my colleagues, all of us in front of a computer, and the computer is part of the mob, not the thing that we have to convince that our ideas are worth having, So, I really hope that I've managed to convince you to care about this. But if nothing else, remember that you are creative. You're important. You don't just do what someone has told you to implement in exactly the way they told you to implement it. I bet every single one of you has had a conversation with your technical and non-technical colleagues where they try to tell you not just that this thing needs implementing or that this piece of logic needs changing, but also how to do it. And you have fought back and said, I'm an expert. I know how to do this. And if I don't know, I'm going to go figure it out. You probably didn't get into this industry to put brackets in the right place. At least I didn't. I don't know about you, but I'm willing to bet that you didn't. You came here to solve problems, or to fix inefficiencies, or to democratize what we currently consider luxuries. You probably came into this industry to understand the processes behind all the ways in which we operate as a society. You're here to improve the lives of yourselves and others. That's what software developers do. We don't take what we have for granted. We keep and just assume that it's always going to be that way. We keep improving, we keep iterating, except on our own tooling, right? The world is so much better now that I can, book a restaurant on my phone, or order a taxi, or just get on with my life without having to jump through the bureaucratic hoops that I used to. But for some reason, as software developers, we deal with those bureaucratic hoops every day, and we don't even realize we're in this cage of our own making. So I would just like you to be more human. And I think being human means teaching a machine to do the mechanical parts. Because after all, we are our choices. That is the end of my talk. Thank you very much for coming. I'm going to find out what your question is in 1 second, but first I just want to explain. I have some links for you. The very top one is my Twitter. Noodlesandwich.com is where you can find all of the content for this talk written down, because I cannot give a talk without writing it down first. Snoopy is available on GitHub and on NPM. You can run it. Please try it out and let me know what you think. You can tweet me. Alfie is the product I showed third, and Toybox is our demo environment for ML stuff, in which you can find the autofix and the type checker, among other things, if you want to play around. What was your question, sir?
Hello.
Hello.
My name's Alfie, by the way.
Oh, cool. Sorry, we named our product after you, but I hope you don't mind.
Is JavaScript the language you focus on primarily? Have you looked at C# or .NET's Roslyn library? Because you can do a lot of these things simpler, I think.
We chose JavaScript for 2, maybe 3 reasons. And it's absolutely not the only language we should be focusing on. It's just the language we started with. The reasons were that JavaScript tooling sucks compared to what we're used to in the worlds of .NET and JVM. It's really, it's good, but it's not nearly as good as what we're used to, right? I really miss IntelliJ, right? And ReSharper. If I had tools like that working in JavaScript, I would be a very, very happy individual. So that's part of the reason we picked it. And we also picked it because it's an entry language for a lot of people. So the help is, there's more need for tools that help you and not punish you. Linters, are great, but they also are painful, and we just wanted to help people a little bit. We actually started by trying to make linters more understanding of your existing code and not give you the feedback. For example, this line is longer than 80 characters on every single line, and understand your code a little bit before giving you that feedback. That's how we started out, and we kind of shifted a few directions from there. But it's part of the reason I encourage you to go and try this sort of thing, because, well, Roslyn's amazing, and if you have a great head start there, you can go and mine that code pretty quick. Any other questions? Yeah. Okay, cool. Well, if you have any questions you want to ask me in private, you can come grab me. I'm sure you'll be able to find me. And if you have any feedback, just come grab me or tweet me or email me or whatever you want. All right. Thank you very much.